Okay, good evening, grade sevens. This is your flip video for probability. This is your first probability thing for the year. So we're going to cover something that a lot of you already know, but that's not the only reason we're doing it. We're just doing it for review. But the other thing I want to talk about is, and this is just quickly just between you and I just for now, is the difference between experimental and theoretical probability. We're going to do both, but it's kind of a different distinction because they're very close to each other. Experimental probability means that you actually do an experiment to determine the probability, like batting averages on baseball players. Okay, if you follow a baseball player over a period of time, you can determine what the chances are that they're going to get a hit. It's something that you've seen through experimentation. Theoretical probability is a little bit like, well, it's kind of like what we were doing today in the classroom with the problems I asked you. Theoretically, you look at the probability based solely on the numbers. So you don't do an experiment. What you try to do is usually do both, right? You want to be able to back it up with an experimental probability, but sometimes you can't do that. In other words, figuring out the chances of being hit by an asteroid, because we don't have experiments to back it up, we have to go through theoretical probability, that kind of thing. So we're going to work more with that as we get closer and closer towards doing some actual probability experimentation in a day or two. But tonight I want to cover something that a lot of you have trouble with, and that's taking a ratio, or for that matter taking a fraction and turning it into a percent. All right, so bear with me. We'll go through this really quick and give you some practice with it over the next few minutes. Here we go. Okay, this is where some of you get really confused, and I understand it. When someone asks you to take something like a fraction, 9 over 50 or 7 over 16, and turn it into a percentage point, it seems really difficult. And you know what? Without having background as to how to do it, it might very well be. But let me go through this really quickly. For those of you who already understand what I'm talking about, this should be a no-brainer. If you don't know, don't worry, you'll get it by the time we're done. I've got 9 out of 50. So someone goes up to bat and goes up 50 times and hits the ball 9 times. Okay, 9 over 50 is the fraction we're working on, and we're trying to figure out what percentage of the time that person gets a hit. Well, when you come to a number like 50, it makes it easy, because one of the ways to determine the percentage is to make sure that the denominator becomes 100. Okay, whether you have to divide or multiply or whatever the case may be, it has to come to 100. So 9 over 50, if you think about it, is just a matter of multiplying by 2. Okay, so if you multiply 9 over 50 by 2, in other words, 2 times 9 is 18, 2 times 50 is 100, then the answer to this becomes 18 over 100, or 18%. Okay? Now, if you're thinking that this doesn't make sense, I want you to think about it, okay? Par cent, percent. What I've basically done is I've taken my sample size, which is 50. Remember we were talking about samples when we were doing data management. I've doubled my sample size, and therefore I have to double what my results were. If I'm doubling the denominator, I have to double the numerator. So the same thing would stand true if I was looking at 1 over 4, okay, 1/4. What would I multiply that by to get it to 100? Well, I'd multiply it by 25. Oh, by 25. There we go. So if I multiplied it by 25, I'd have 25 over 100, or 25%. So if it makes sense to you just by looking at it, that you can easily change the denominator to a 100, okay, quarter of 25, whatever the case may be, you can do it this way, and you're going to be right every single time. The problem is when you get into numbers like 7/16, okay? The problem with 7/16 is there's no easy way to turn that denominator into 100. And the best way to do it is going to seem really simplistic, but it's absolutely it's absolutely the truth. Let me show you. If you take a calculator and you divide 7 by 16, well, that's what a fraction is, if you think about it, right? That little thing here. In fact, it even shows here on the calculator. That backslash means divide by. So 7 divided by 16 will give you a percentage. 7 divided by 16 equals 0.4375. Well, how is that a percentage point? Well, 0.4375, okay, hang on a second, got to bring it down here. 0.4375 is the same thing as 43.75%, which, if you need to round it up, is 44%. Okay? I'm going to give you a bunch of examples. There's only 12 of them. Work through them tonight, see if you feel comfortable with them, and then tomorrow we're going to start combining both the idea of theoretical, experimental probability, and making sure that you can do these so we can get ahead of the game here over the next little while. Okay? Good luck. Run through it, and we'll see you tomorrow.